What's the value of flux? BA cos theta.
Yes, sir.
Right. Now, you have EMF, right? EMF is what? Minus d phi by dt.
Delta T.
Minus d phi by dt. Okay. And the flux
Yes,
is
sir.
d phi by dt. So what are the ways I told you can change the flux? Either
So
by changing the
yes,
magnetic
sir.
field, or changing the area, or changing the
Theta.
theta value. Either you can do by changing the magnetic field, area, or the theta value. Okay. Now you see here what is going to happen here is, okay, now what you see is going to happen here is, now flux, if I'm changing, I will show this example. Do you have your textbook with you?
So I will have to open the PDF.
Okay. Laptop the PDF you have. Okay. So
Yes.
now you see,
Should I open it, sir?
yeah, can you come to page number 436?
Just a second, sir.
Can you come to page number 436? 1 second.
56 of the PDF or the book, sir?
Book.
Book page
Yeah,
number.
come to page number.
Yes, sir. Yes, I'm on 436.
Yes. Yeah, did you open it? 1 second. The problem here is my kid is making too much of noise here. Okay, very sorry about it. Okay. All right. Okay. Now, just a small disturbance. Very sorry about it. Okay. All right. Now, are you able to see? I'm making a.
No, sir, I cannot see that. You'll have to scroll down a bit.
No. I'm making it on the page. I'm making it on the page. Can you see? On the whiteboard.
Yeah, sir, I cannot see it. I can just see the starting of it, I think.
Why the whiteboard is not working? 1 second. Can you see the whiteboard?
Yes, sir, I can see the whiteboard, but I cannot see the entire. I think you have to scroll down a bit on your whiteboard so that I can see.
It's not seen.
So I can scroll down on my screen also. I can see it now. Yeah.
Zoom is really okay. Fine. Yes. All right. Now I'm making a coil. Can you see?
Yes, sir, I can see it.
I'm making a coil, and in this coil, I'm connecting a ammeter. I'm connecting a ammeter. Okay. Now I'm bringing a magnet nearby. Okay.
Yes, sir.
You have a north pole of the magnet and you have a south pole of the magnet. Okay, you have a north pole of the magnet and you have a south pole of the magnet. Now, when I bring the magnet near the coil, do you feel that there is going to be any sort of current being produced?
Sir, if the magnet passes through the coil, then yes, but near the coil, I'm not sure.
I'm just moving the magnet a little bit closer, or I'm moving the magnet upwards.
No, sir, I don't think so.
Why it will not get produced?
So, because
okay.
yes, sir.
Now you see here, we have coils, right? Round coils.
Yes, sir. Yes, sir.
So these round coils have an area.
Mm-hmm.
Yes, and when I'm keeping a magnet, magnetic field is passing through it, right? Yes.
Yes, sir.
And because of the magnetic field, you have a magnetic field B.
Yes, sir.
Magnetic field B, right? And you have area vector also, so that there is an angle between area A and magnetic field B. That's why you have theta also.
Yes, sir.
So you have a magnetic flux linked with it.
Yes, sir.
Okay, so there are how many coils here? This is only for one single coil. Imagine there are 1, 2, 3, 4, 5. Imagine there are 5 circles.
Okay, sir.
You have 5 circles, right? So your magnetic flux will be 5 times.
5 times.
5 times, right? Your magnetic flux is going to be 5
5
times
times.
of the 5 times of the flux. Yeah, the magnetic field 5 times of the flux. All right. Now, what is the flux here? B A cos theta. Flux here is B A cos theta. All right. And 5 times B A cos theta. The total flux is 5 times. Why 5? Because there are
There are 5 loops.
5 loops. So 5 times B A cos theta. All right.
Yes, sir.
Now, you see what is going to happen. When I'm moving the magnet, what is going to change out of this? When I'm moving the magnet, what is going to change out of this? When I'm moving the magnet, what is going to change out of this? Is A going to change, B going to change, or theta going to change?
Just a second, sir.
When I'm moving the magnet up and down,
A will remain constant.
but A will remain constant.
Yes, sir.
Theta also will remain constant, right?
Yes, sir.
Then what is going to change?
B will be changing.
B will change, right?
Yes, sir.
So what happens due to this changing B? Right? Due to this changing B, you are going to have a EMF induced.
Yes, sir.
Okay, so what I'm trying to say is in this example, when you have a coil and when you move the magnet, you are going to have a EMF induced.
Yes, sir.
You are going to have a EMF induced. Okay, so this is one method. Next method I will show you. Next method, which is usually called as motional EMF. Yesterday we saw motional EMF, right?
Yes, sir.
What was happening in the motional EMF? Can you tell me? We had one wire like this, and we had a magnetic field in this way, right?
Yes, sir.
We had a magnetic field in this way. Right. Then you had a wire which was moving in the velocity v.
Yes, sir.
Okay, you had a wire which was moving in the velocity v. Now, this v, all right, because of this, what was changing for that loop? See, this is a loop. As you can see, this is a loop, right?
Yes, sir.
What was changing for this loop when this was changed?
Sir, yesterday we did it only for a single open wire. We did not do with a loop.
Yeah, we did for single wire loop only.
Yes, sir.
Single wire, right? So now when this wire is moving like this, what is changing?
Yes, sir. The velocity is changing.
Yeah, of course, you have velocity. See, you have one side like this, and when this is becoming here, what is getting changed of this loop? When this is coming here, what is getting changed?
The area.
The area is getting changed. So in this place also we saw there is a production of velocity, a production of EMF.
Yes, sir.
So we have seen B, we have seen A, we have seen theta. We have seen B, we have seen A, we have seen theta. All right.
Yes, sir.
Now, sorry, B is done, A is done, and how about theta? Do you know? It's just overview. How about theta? Do you know how we are going to change theta?
Sir, yesterday you changed theta by moving the frame, by moving the loop. Like the example you gave for one, it was like this in first case, and in second case it was like this with the same magnetic field. So the theta changed.
Very good.
From 90 to 0.
So I'll say like this. I will come to the new page. I will show you one case like this. You have a magnetic field. Let me draw a straight line. You have a magnetic field like this. You have a magnetic field like this. Okay. Now, in this magnetic field, I have an area. Yes.
Yes, sir.
First, the area is like this. Then, what happens to this area? Then this area becomes like
It
this.
is rotated.
Rotating. Okay, I'm not able to rotate here. This area is becoming like this. So it's just rotating like this. I will show you with an example of, yeah, this is a magnetic field. Okay, as
Yes,
you
sir.
can see in the camera, this is the magnetic field, and this is rotating like this. So what is changing?
So the theta is changing.
The theta is changing. Is the area changing?
No, sir.
Is the magnetic field changing?
No, sir.
Only theta is changing, right?
Yes, sir.
So in this is the case where you see that EMF is getting induced.
Okay, sir.
Okay, this is the case where EMF is getting induced. All right. So you will be looking into it. Okay. So 3 ways of producing EMF. One is magnetic field, other is area, another one is changing the theta.
Yes.
So you have understood these 3 methods.
Yes, sir.
All right. So these, by changing all these things, what am I changing? I'm changing the flux. Okay. I'm
Yes, sir.
changing the flux in this case. All right. Okay, fine. So I hope this thing is clear to you. Now let
Yes,
me
sir.
bring you back to this loop. Okay. Let's come back to this situation now. Let me, yes, come back to this situation. That is page number 1. Are you able to see page number 1?
Yes, sir.
Okay. Now I'm putting a question for you. Okay. I'm putting a question for you. The question is, you saw that magnetic EMF was getting produced when you are moving the magnet.
Yes.
What are the ways how I can create more EMF?
So one is increasing the number of coils, number of loops.
Very good. Increasing the number of loop will increase the EMF value. When you are
Yes, sir.
increasing the EMF value, you are going to increase the, when your flux value, when you're increasing the number of loop, number of flux value increases.
Increases.
As flux value increases, the EMF produced also will increase.
Yes, sir.
Right. So one thing how I can change or I can create a more EMF here is by increasing the number of loop. Here I have 5 loop, but if I want to create a more EMF, I will use 10 loops maybe.
Yes, sir.
Loop will give me double the EMF.
Yes, sir.
Loop will give me double the EMF value. But same way, in the same way, there is one more method of increasing. Do you know what that method is? Same. I have to just do something very different. I have to move the magnet, of course. When I move the magnet, EMF is going to be induced.
So
But
using a stronger magnet.
no, magnet area is remaining same.
Okay.
One is loop. What can be the other?
Just a second.
What can be the other one in this case? What can be the other one?
I'm not sure, sir.
Okay, just see here. dB by dt. Here, dB by dt is a cause why the magnetic flux is changing, right? How can I make this more? How can I make this more? How can I make the rate of change of magnetic flux more? And any possibility that you remember, as any possibility that you know, how to make it more. One is by increasing the number of loops that you told.
Yes, sir.
One is doing it faster.
Okay.
The change should be faster. That means if I take a magnet and do like this, that will create a slow EMF. If I take a magnet and do very fast, that is going to create a greater EMF.
Greater EMF. Okay.
Okay, that is going to create a greater EMF, and this is how you can increase the EMF value of this. Is that clear to you?
Yes, sir.
Okay. So you can do the opposite, say other way also. You can keep the magnet and you can
Move the coil.
Coil. Yes, you can move the coil nearby faster. That is also one way of doing. All right.
Okay.
Great. Okay. So I hope this particular concept is clear. Till here, yesterday's class and today's class is clear to you.
Yes, sir.
All right, because I'll be in between, I'll be asking the questions so that to know that you are not forgetting these things. Okay, make sure that you're not forgetting all these things. All right, one more. Okay, now let me ask one more question. In what case I will get maximum flux? That means what are the cases? Like, tell me in terms of rotation. B is same.
Okay, in terms of rotation.
Yeah, B is same, A is same. So I can change only theta. Okay, I can change theta now. Now, in which condition your flux will be maximum?
Sir, 0 degrees.
0 degrees. Why?
Sir, because cos theta is 1.
Cos 0 is 1. Very good. So when the angle between the B and A is 0, that is when your angle, that is when your what do you call the flux?
Magnetic flux will be greatest.
Okay. So yes. All right.